Let's see how to find the direction of electric field. Suppose I take an isolated positive charge. So you know what is the meaning of an isolated positive charge, right? There is a system which has only one positive charge. Okay. So what is this charge? Is it the source charge or a test charge? This one. So it's a source. It is the one which is creating the electric. So if I place a test charge here, which is Q naught, in which direction will it experience a force? Will it experience a force towards the source charge or away from it? It will be away because what did I say? By default, test charge is always positive. So this is going to be the direction in which the electric field is present due to a positive source charge. In a similar way, if I place this Q naught here, for instance, it will experience a force in the outward direction. Makes sense? So if I place it here, it's not like I'm having multiple Q naughts. The same Q naughts position and changing from one point to another. If I keep changing it, it will experience a force like this. So if I see the electric field direction due to an isolated positive charge is going to be always away from it. So what does it signify? That away means that is the direction in which who will move. That is the direction in which the test charge will move if it is free to do so. So what is the important point that we need to make a note here? Who decides the direction of electric field? Direction in which a test charge move if it is free to move. Am I clear with this? Similarly, if I place a negative source charge, due to a negative source charge, what is going to be the direction of electric field? Why is it so? Because if you place a unit positive test charge, it will get attracted. Am I clear with all this? So here an important point to be noted is direction in which the test charge will move if it is free to do is what is the direction of electric field due to that source. So always remember electric field is created by the source charge, not by the test charge. So when someone asks you what is the electric field due to a charge, what charge are they referring to? Source. So every time they not mention source charge, but you should know. We drew these lines around the charge. So I told you two things. One is we understood what is electric field intensity. We understood that it's a vector quantity and how to find the direction. But we have to show a diagrammatic representation of this strength. So for that, what we do is we take these imaginary lines into consideration, which are given a name called as, any idea? They are called as the electric field lines, or they are called as lines of force. They both mean the same. Electric field lines or lines of force mean the same. Okay. And just because we use the word electric field lines, no, they literally do not mean they are lines. They can be curves also. For example, if I take a positive charge and a negative charge, the electric field lines due to this will be like this. Because what is this one telling me? Electric field due to a positive charge is away from it. What is negative charge telling me? Electric field due to a negative charge is towards it. So it starts from a positive charge and ends with a negative charge. So here also the same thing happens. Right? So it will be something like this. Going like this. What are these curves called as? They are called as electric field lines, or they are also called as lines of force. Okay. With this, we have built the basics that are required for derivation. Next concept onwards. Maybe we'll have 30 more minutes of theory discussion. After that, everything else is derivation. Which is important. Okay. So make sure that these basics are strong. Okay, I want to show you one thing before winding up the class. If I place an isolated positive charge here, look at what is it. So this is what we do. So what is the meaning of this is, what did we discuss? The direction of electric field is decided by whom? So the direction of electric field will exist for a source charge, but it is decided by a test charge. That's what I told you in bracket I wrote. Direction in which the direction of electric field is the direction in which the test charge will move. Right. So here test charge is basically the sensor. So if I place the sensor here, are you able to understand what is happening? Due to this positive charge, it will experience a force in this direction. So like this, if I move the sensor to any point, see. So if I bring it closer, no, you're able to see that the strength is more. That arrow mark has disappeared. See, when I take it away, look at the size of the red color arrow mark. When I take it close, what is it telling me? It will experience more force. That's what Coulomb's law states, right? Because it's a point charge, it's inversely proportional to R square. Closer the distance, greater is the force. I hope this point is clear. Now, if I clear the system, right? If I take a negative charge and place it like this, then you're able to understand. So if I place a sensor here, the discharge will tend to go and get attracted to the source charge. Okay, this is also simple. Now, it is all not necessary that you always have a positive or a negative charge. You can always have a combination. So when you have a system like this, positive and a negative. So you're able to see what is happening here. Because going from the positive and ending with the negative. Going from the positive and ending with the negative. Right. So you would have seen something similar in magnetic fields. What happens there in magnetic field lines? It starts from the North Pole, goes to the South Pole, and South Pole to North Pole inside the magnet. Whereas electric field lines do not form a closed. They start from the positive charge into the negative charge. If you see the diagram that I do also, it starts from the positive edge with negative. I never draw through the line in reverse. Okay. So electric field lines do not form a closed loop. Now, what is the other combination that is possible? Now I took unlike charges. Obviously, I need to take like charges.
Like charges.
So what will happen here is, due to the positive charges, it's always away, right? These lines are there, no, they will never meet. They actually get bent like this. They meet only at infinity. They become parallel to each other. Here it is not clear because they didn't draw the arrow mark clearly. It will get bent like this and move. So if you want to observe this diagram in your textbook, it is in page number 25. On the right hand side, you have a diagram. So that's what I have shown you. But now are you able to understand what is the meaning of it? You need to understand the significance. If this is clear, next part and all, smoothly. It's a very simple chapter. Very good, you're able to visualize. So this is what I wanted you to think about. About voltage, using the same logic, I'll show you the next chapter because their potential comes, electrostatic potential, that chapter. Here it's only about fields. We'll see this one. Here. So next class we'll start with the properties. Right. So I'll try to give you an assignment maybe for 7 to 10 questions based on concepts that we have discussed till now. So complete it and upload it to me. Okay. So only thing is be on par with the syllabus. Will be in parallel. Don't say that you're going to study in the last minute, you become everything.